Hello everyone. Welcome to the class of E-Plan and Electrical Control Technology. Filling machines are widely used in the beverage, condiment, and pharmaceutical industries. By utilizing advanced filling control systems, businesses have significantly improved their efficiency. With the advancement of technology, an increasing number of automated control systems are being applied in the filling process, leading to a wider range of applications for filling machines. In this class, we will design an electrical control system for a simple filling machine. First, let's take a look at the process requirements for the filling machine. Simply put, the electrical control principle of the filling machine comes down to the control of the motor. To ensure that the motor operates normally according to the requirements of the production machinery, we need to equip the motor with certain electrical control and protection devices and establish specific control circuits to achieve filling control. During filling, it is required that the motor starts and continues to run. Pressing the continuous filling button starts the motor, which will continue to run. The system employs a contactor self-locking control circuit for forward rotation to achieve continuous filling. Press the inching filling button to achieve inching filling and ensure the correct quantity. Inching control adjusts the state. When you press the start button once, the motor starts rotating. When you release the button, the motor stops. When you hold the button continuously, the motor rotates continuously. When you release the button, the motor stops. This state is often referred to as inching or inching mode. Continuous control makes a state continue. It makes the motor continuously run with one button pressing. That is, when the start button is pressed, the motor starts to rotate, and when the button is released, the motor continues to run. This state is commonly referred to as continuous running or long mode. Having understood the process requirements, let's analyze the working principle of the filling control system. The electrical schematic diagram of the simple filling control system consists of several parts, including the main circuit, control circuit, protection, distribution circuit, etc. We can understand the working principle of the entire filling system if we know the category, structure, and wiring of each part. The electrical control principle of the simple filling machine is shown in the diagram. The circuit primarily consists of the main circuit and control circuit. In the control circuit, start button SB2 controls continuous mode, while button SB3 controls inching mode. Now, let's take a look at the working principle of the control system's inching, continuous mode, and relevant protection circuits. First, the inching control of the motor. Its working principle is as follows. Press the start button SB. Contactor KM coil is energized. KM main contact closes. Motor starts rotating. Release SB button. Contactor KM coil is de-energized. KM contact opens. Motor stops. Next, the continuous control of the motor. Its working principle is as follows. Close the QS switch. Press the start button SB2. Contactor KM coil is energized. KM main contact and self-locking contact close simultaneously. Motor M rotates continuously. Press the stop button SB1. Contactor KM coil is de-energized. KM self-locking contact and main contact open. Motor M stops. Next, let's learn the circuit protection. The circuit mainly consists of three types of protection: short circuit protection, overload protection, and zero voltage protection. Short circuit protection requires instantaneous action, meaning the power supply must be cut off in a very short time. The short circuit protection device used in this project is a 3-level fuse. Overload protection refers to when the motor's operating current exceeds its rated current, but stays within 1.5 times the rated current. The overload protection device used in this project is a 3-level thermal relay. Zero voltage protection is also known as no voltage protection. When there is a power outage or voltage loss, the breaker of the protection circuit will automatically trip, realizing interlocking. The contactor used in this project has zero voltage protection capability. Next, let's combine inching control with continuous control to meet the inching and continuous control requirements of the entire control system and also provide protection. After the schematic diagram design is completed, the next step is equipment selection. There are many types of equipment for simple filling control systems. When companies choose equipment, they should select equipment that matches their own conditions and production needs, focusing on high production efficiency. Generally, primarily 3 factors are considered during equipment selection. Firstly, equipment should be suitable for production. It should be compatible with the company's production scale or requirements. Secondly, it should be technically advanced. After satisfying the first requirement, it should have performance indicators that are at an advanced level to enhance product quality and prolong its technical life. Thirdly, it should be made economically reasonable. To name just a few, its price should be reasonable. It should have low energy consumption and maintenance costs. It should meet energy consumption requirements. All right, next, let's select the electrical equipment required for the system. Let's start with the selection of circuit breakers. The selection of accessories for the entire system is based on load power. And here we choose according to empirical parameters without precise calculations. Let's start with selecting the wires. The rated current of the 3-phase induction motor is calculated based on an empirical value of 2 amperes per square millimeter. The current for 0.75 kilowatts is 1.5 amperes. Theoretically, 1 square millimeter of copper core wire is sufficient. However, considering the on-site environment, we choose 2.5 square millimeter multi-strand soft copper wire with a current carrying capacity of 16 amperes. Now let's choose the circuit breakers. Since it's a 3-phase induction motor, we choose a 3P circuit breaker. The rated current of the circuit breaker is larger than the load, but smaller than the wire size. So we choose 10 amperes. Considering the above 2 points, we consult Chintz circuit breaker selection table, and finally choose DZ47-60 3P D10 amperes, or NXBE-63 3P D10 amperes. The NXBE-63 series is an upgraded version of DZ47-60. Next, let's select the fuses. First, let's choose the fuse elements. For the main circuit, we choose a fuse element that is 1.5 to 2.5 times the load current. So we select a 2A fuse element. By referring to the selection table, we select RT28-632 amperes. Since the control circuit has a lower current, we also choose a 2A fuse element. By referring to the selection table, we select RT28-322 amperes. Next, let's select the fuses. Fuses are mainly used in conjunction with fuse elements. After consulting the table, we choose RT28-63X base 3P for the main circuit and RT28N-32X base 2P for the control circuit. Now let's look at the contactor selection. The current in the main circuit is approximately 1.5 amperes, so we just need to choose a contactor with a rating one level higher than 1.5 amperes. After consulting the table, we chose CJX2-0910 380 volts. For the contactor auxiliary contacts, we select those matching CJX2 series contactors. The difference mainly lies in normally open and closed contacts and numbers. The price is similar. For versatility, we choose F4-22 after consulting the table. Next, let's choose the button switches. We choose the Chint NP2 series switches, taking into consideration their control functions. We select green for the inching control button, black for the continuous control button, and red for the stop button. Finally, let's select the thermal relays. The load current is approximately 1.5 amperes, and the setting current of the thermal relay is 0.95 to 1.05 times the load current. After consulting the table, we choose JR36-20 with a setting current of 1 to 1.6 amperes. I led you through the design of the electrical control system for the filling machine. The content includes the requirements, working principles, and equipment selection for the filling machine. After mastering the design for the filling machine, we can apply the same principles to other designs and projects. That's all for this lesson. See you next time.